for which values of r is the integral 0 to 1 x to the r dx convergent. If r is greater than or equal to 0, then x to the r is a continuous function on a closed interval 0, 1, and the integral exists. For example, the integral from 0 to 1 of x dx, the integral from 0 to 1 of x to the 1/2 power dx, those integrals exist. If r is negative, then the limit at x goes to 0 from the right-hand side of x to the r is infinity. Thus, this is improper and we have to take the limit. We have the limits at t go to 0 on the right-hand side of the integral from t to 1 x to the r dx equals the limits at t go to 0 on the right-hand side of x to the r plus 1 over r plus 1 evaluated at t to 1. This is 1 over r plus 1 times the quantity 1 minus the limits at t go to 0 from the right-hand side of t to the r plus 1, provided that r is not equal to negative 1. If the exponent r plus 1 is positive, that is, r is greater than negative 1, then we have the limits at t go to 0 on the right-hand side of t to the r plus 1 equals 0, so the integral is convergent and is equal to 1 over r plus 1. If r plus 1 is negative, that is, r is less than negative 1, then the limits at t go to 0 on the right-hand side of t to the r plus 1 is infinity, so the integral is divergent. With the case r plus 1 equals 0 or r equals negative 1, this integral is 0 minus ln of t, and as t go to 0 from the right-hand side, ln of t go to negative infinity, that the integral is divergent. Thus, this integral 0 to 1 x to the r dx converges only when r is strictly greater than negative 1. If we write x to the r as 1 over x to the p, then p equals negative r. Thus, the integral from 0 to 1 of 1 over x to the p dx is convergent if p is less than 1, and it converges to 1 over 1 minus p, and it is divergent for p greater than or equals to 1. This is called the p integrals, and we will be using these often from now on. For example, the integral from 0 to 1 of 1 over the square root of x dx, we know that this is convergent because p equals 1/2 in this case, which is less than 1, convergent. For the integral from 0 to 1 of 1 over x to the 5/2 dx, we know that p is 5/2 in this case, which is more than or equal to 1. Therefore, the integral is divergent right away without having to evaluate them.